Good morning and welcome to Module 6, Lesson 7. We are focusing on 8F4, all about linear relationships between two quantities, bivariate data, and scatter plots. By the end of this lesson, you'll be able to distinguish linear patterns from nonlinear patterns based on scatter plots, and you'll know you're successful when you can identify those patterns and describe the different unusual features in scatter plots, such as clusters and outliers, okay? We're going to go ahead and get started with some examples. You'll do some exercises for practice. We'll close out the lesson with a summary. You'll do your exit ticket in Galileo, and then you'll complete a lesson reflection. Please make sure that you are following our class expectations as we work today. All right, just to kind of remind you of some background stuff we've already learned about. In the previous lesson, you guys learned about how scatter plots show trends in bivariate data, which is just two variables being graphed, okay? So when you look at a scatter plot, you are asking yourself these questions, and we're going to be doing this today a lot. Does it look like there's a relationship between the two variables? If there is a relationship, does it look like it's linear? Does it look like it kind of forms a line? And then if it is linear, is it positive or negative? Is it going up or down, okay? So to answer the first question, we're going to look for patterns in our scatter plot. Does there appear to be like a general pattern to the points in the scatter plot, or they just look completely scattered and random? If there looks like there's a general pattern, then we can say yes, there's a relationship here. If you see a pattern, you can answer the second question, which is it a linear pattern? Can it be described by a line? And then once we do have a line, we look and we see, does that line look like it's going up or down? Is it going to be a positive linear relationship or a negative linear relationship? Okay, so that is what we're going to be doing today. And later we will be kind of just describing these relationships a little bit more, and we'll be talking about a few different vocabulary words called clusters and outliers when it comes to scatter plots. All right, so starting with example 1, we're going to ask ourselves these 3 questions and then answer them off to the right. It says, take a look at the following 5 scatter plots, answer the 3 questions, scatter plot 1. Here we go. So it looks like we have a bunch of little dots here. You can look at our x-axis and our y-axis and kind of see that our numbers increase going left to right and increase going top to bottom. And what I'm going to notice here is there a relationship, or what I'm trying to notice is there a relationship that I see here? And I do. I definitely see that these are kind of starting out up here and then kind of forming this downward trend. So it looks like there is a relationship. So that relationship basically shows me that when our x value is lower, so like at 0, our y value is higher, okay? So the higher our x value goes, so we go from 0 to 10, right? The lower our y value goes. These points right here are now around this area. And then the highest one here is the lowest one on our y-axis. So yes, there is a relationship here. And then the second question it asked me is, does it appear to be linear? Well, you can already see that I kind of drew a line. This is called a line of best fit, and we'll be working with this a little bit more tomorrow. I drew a line of best fit, just a line that kind of goes through most of these points, showing the general line that it forms. Now, it does not form a perfect line, but this relationship is forming a trend that is a linear trend. So yes, this is appearing to be linear. You can see that it makes a line. And then the third question says, if it appears to be linear, is it positive or negative? So if we look at this from the left side to the right side, is it going up or down? It's going down. You can kind of see it looks like it's going downstairs, right? You're decreasing as you go from left to right. So this is a negative linear relationship. And so this is how we're going to start off our lesson today. I'll do a couple more with you, and then you'll do a couple on your own. And then we'll take it a little bit further and kind of analyze our data a bit more. Please make sure you have this down before we move to the next slide. All right, example number 2. We're going to ask ourselves again, is there a relationship? So as I'm looking at my x-axis and I find a dot right here. So this x-axis, this first dot on our x-axis falls right around 50 and it is below 1. So pretty low x and a low y. And then if we get a little bit higher on our x, we get a little bit higher on our y. This one is not as high on our y, but it's still, kind of following that same pattern. This one, higher on our x-axis, higher on our y. And stay the same. This one, higher on our x-axis, higher on our y. So this does form a general pattern. In general here, the larger our x value is, the larger our y value is. So it looks like it's forming a relationship. So our answer for that first question is yes. It does look like it's forming a relationship. As x increases, y increases. If there is a relationship, does it appear to be linear? Yes. I drew a line of best fit already. It kind of creates this line going upward, and that answers my third question, which is this a linear positive trend or a linear negative trend? This would be positive. Right? We're increasing from left to right. It looks like we're going upstairs. Okay? My stairs are terrible. I'm sorry. Go ahead and make sure you have this down. We'll do another one together, and then I'll have you do a few on your own. Okay, looking at scatter plot 3, we're going to look for a relationship. So if I look at my x, I want to see, is there any correlation with my y? So this x value is right about here. My y value is right here. And then I stay the same x value, and then I go right here. And my x goes up, and my y goes up a lot. My x goes back down to 0. It stays at 0, or my x goes down up to a little under 2, and my y stays at 0. This one's right about here for my x and y. You'll see this is not forming any type of trend or pattern. These are all over the place, right? There is no line of best fit that I can draw. If you were to draw a line to connect these, it's like very crazy, right? There is no relationship. And so because there's no relationship, we can't answer this. This is not applicable. And we can't answer this. This is not applicable either, because we can't answer if the relationship's linear. And we can't answer if it's positive or negative because there is no relationship. Okay? Make sure you have this down and we will move on. All right, for example number 4, I want you to take a couple minutes to try this one on your own. Answer the 3 questions off to the right, and then we'll go over it very shortly. All right, you should have noticed that there is a relationship here. One thing I do want to point out is that there is one point over here that is kind of throwing everything off. So if you ignored that point and looked at this, it would have been super easy. You're like, oh yeah, I can definitely see that there's a relationship, right? It's definitely a relationship with these over here. As x increases, y increases. But this point over here that I highlighted kind of throws it off. What I want to point out to you is that sometimes scatter plots have these points, and these are called outliers. Oops, did not mean to go that far in. Outliers are just points that are just kind of throwing the entire relationship off. So outliers in real life, if we were talking about like real life situations that you're graphing, it's maybe like, say you're doing a graph about like kids' IQ scores, right? There's obviously going to be some kids out there who are really, really, really like just smart at a young age. So maybe if their age was low, their IQ would still be pretty high. Okay, because they're just a child prodigy or a genius or something, and that would be an outlier. That's not the majority of kids. That's just one kid that's just kind of like very different from the majority. All right, but anyways, you should have noticed that yes, there is a relationship. yes, the relationship is linear. I already drew the line to kind of show you it's going up. And if it's linear, does it appear to be positive or negative? Well, going from left to right, this is going up stairs. So this is positive. Let me know if you have any questions before we move on to the next one. All right, please try example number 5 on your own. Identifying the relationship here, if there is one, if it's linear, and if it's positive or negative. All right, the first question is the relationship. Now, a lot of these points just look like they are clustered in here. So that is another word I was going to teach you today. This is called a cluster. Sometimes we have really big like sections on our scatter plot where dots are just like clustered all together in one section. Okay? And like an outlier, it gives us important data. But is there a relationship here? Yes, there is. It's very hard to see because there's a big cluster in the middle, but this is a relationship. As our x value increases, our y value is decreasing, right? So over here, when my x is like at a 1, this is when it is the highest on the y-axis. Over here, when my x is at a 5.5, this is when it's lowest on the y-axis. Okay? So yes, there is a relationship here. Does it appear to be linear? Well, does it appear to form a line? Yeah, even though there is a huge cluster right there, it is having this trend where as x increases, y decreases, so it is kind of forming this linear pattern. And if we look from the left to the right, we are going downstairs. So this is a negative linear trend. Okay, please make sure you have this down, and we'll get into a little bit more analyzing on the next few examples. All right, with example 6, we're just going to go a little bit deeper with just describing our relationship. So instead of having those 3 questions to prompt us, we're just going to make our own answer based on those questions, okay? So it says, below is a scatter plot of data on weight in pounds and fuel efficiency in miles per gallon for 13 cars. Using the questions at the beginning of this lesson as a guide, write a few sentences describing any possible relationship between x and y. So remember, this is our x, this is our y. So if you think back to the beginning of this lesson, the first question was, is there a relationship? So I can see that there is a relationship. Between x and y. Which was between weight is our x, okay, so it's between the weight of a car, and our y variable was fuel efficiency. Okay, and then we want to talk about, is it linear and is it positive or negative? So it appears to be linear. Let's just actually go ahead and say it appears to have a negative linear relationship. Basically saying that as the weight increases, the fuel efficiency decreases. Okay, so I'll give you a moment to write that down, but I just want to point it out. So the lighter the car, the more it travels with the same amount of gas, right? It has a better fuel efficiency. And this is kind of common knowledge. If you have like a huge truck or something, usually big trucks don't get very good gas mileage. You have to fill them up more. Usually tiny cars that weigh a lot less can travel a lot further for the same amount of gas. Okay, so go ahead and make sure you have this down. I'm just going to highlight the 3 parts. So we found that there is a relationship. We found that it appears to have a negative linear trend. And then we just describe that trend. So as the weight of a car increases, the fuel efficiency decreases. Okay, make sure you have it down, and we're going to move on to the next one and do the same thing. You will have to do this on your exit ticket today, so just make sure you know how to pretty much just put your answers into sentences based on your graph. All right, again, we're going to be answering these questions based on this graph. We want to write a couple sentences about this relationship. So looking at these points, first thing I want to say is there a pattern? Do I see any type of trend? Well, to be honest, I don't really see any trend. It's just kind of scattered here in this cluster. So there's no trend or no pattern. Okay. I don't see any line being formed. It just kind of looks random. So I'm going to say the price, which is X, does not seem to affect the quality rating. Which was our Y. So it doesn't look like there's any relationship between our price of something and the quality rating of something. Okay, and I wrote 2 sentences. I only needed to write 2. So that is my answer here. Just make sure you have it down. All right, based on what we just did in the last 2, I want you to try this out on your own. So write a few sentences describing any possible relationship between X and Y. Go ahead and get this done, and then we'll go over it. All right, you should have noticed that there is definitely a trend between your X and Y. So as shell length, which is our X, increases, age also increases, which is our Y. Okay, the relationship between these 2 variables is positive. Okay, because as shell length increases, our age also increases. So here would be our line of best fit right here. And you can see that it's going up. So only thing I needed you to point out is that yes, there's a relationship, okay, and it's a positive one. All right, let's try it one more time on example number 9. All right, go ahead and try out example number 9 on your own as well. Write a few sentences regarding this scatter plot and the relationships you see here. Okay, you should have written something similar to what I've written here. There is a pattern, or there is a trend between the 2 variables. As body mass, which is your X, increases, bite force, which is your Y, also increases, making this have a positive trend. positive, I'm going to say positive linear relationship. Okay, so again, there is a trend. As the body mass increases, bite force also increases, and this has a positive linear relationship. All right, make sure you have that down. And we're going to get into a little bit more talk about outliers and clusters. All right, so in addition to looking for a general pattern in scatter plots, you also want to look for a few things that are interesting about your relationship, and these things are called clusters and outliers. So clusters are points in a scatter plot that form like a cloud of points. Okay, so these are like little sections where there's a big set of points. It's called a cluster. Okay, and that might tell you something useful about your data. An outlier is an unusual point that does not fit the pattern. It's kind of like far away from the other points. Okay, so if we look at this graph right here, we're going to be noticing some clusters and some outliers, and we'll get into that on the next page. So what I want you guys to do in your breakout rooms is looking at this graph right here. I want you to ask each other and come up with an answer. Do you notice any point in the scatter plot that might be described as an outlier? So a point that's kind of just out on its own, and if so, which one? So I want you to maybe like circle it or something. Okay? If you did identify an outlier, I want you to write a sentence describing how this might be different from the rest of the data. Okay? And then, do you notice any clusters in the scatter plot? How would you distinguish between the clusters? Why do you think that they're there? Okay, and we'll go over this in about 2 to 3 minutes. You're going to go do this in your breakout rooms together, and then we'll come back together and go over it. All right, starting with question number 1, you're looking for an outlier. If we look at this graph, the only outlier that's really kind of like away from everything else is this point right here. So this is a possible outlier, and I'm going to write about that one here. So yes, there is an outlier. And this outlier is right at about 100, 100. Approximately 100 on our x, 100 on our y. Okay, so using that outlier for the next question, why is that different from the rest of the data set? Well, this point is tremendously lower than all the rest of the x and y. So this animal, I'm guessing it's an animal, the chest girth was the lowest. It was below 100, and it was right at 100 pounds in weight. So it was a lot lighter than all the rest of these points, and had a lot smaller chest girth than the other ones. So what could that mean? Maybe this was, if they're doing this on elk weight, maybe this was a baby or something, right? So one sentence describing how this differs, it is a lot lighter and smaller than the rest of the points or the rest of the data. We said maybe it's a baby. Okay, and then it says, are there clusters here in this scatter plot? Well, yes, there are definite clusters here. So I have a cluster of points right around here. It looks like I have a cluster of points right around here. And then I have a cluster of points right around here. What does this mean? Well, maybe this is just like the age of these elk, right? So maybe this is like kind of like a teenager elk, and it's about 200 pounds and has a chest girth about 110. Maybe these are a little bit older. Females, maybe advanced or fully adult females. They're a little bit heavier, 250 pounds, right around this area for chest girth. And maybe these are like the adult male elk, which male species are generally a lot heavier and bigger than the rest. So that's going to be my answer here. Yes, oops. There are clusters. I think that the reason these clusters have occurred is that maybe the clusters are there. Oops. Because the elk are different ages or genders. That's what I'm thinking. Okay? So go ahead and make sure you have something like this down. And then we're going to close out the lesson and move into our exit ticket. All right, just to summarize the lesson today, a scatter plot might show a linear relationship or a non-linear relationship or no relationship. A positive linear relationship is used with a positive slope. Negative is with a negative slope. Outliers are points that are unusual and do not seem to fit the general pattern, and clusters occur when it forms some two or more distinct clouds of points, so like a big section where they're kind of grouped together. Okay, let's go over what your exit ticket is going to look like in Galileo. All right, I don't have the actual questions here for you because they're in Galileo, but you're going to have to, for number 1, identify which scatter plot out of 4 has a negative trend. For number 2, you're going to have to write one sentence about the trend you noticed in a scatter plot. We did this a lot in our lesson. For number 3, you're going to have to identify any clusters in a scatter plot. Number 4, identify any outliers in a scatter plot. And then number 5, you have to identify the trend of a scatter plot after reading its description. So you're not going to see it. You could draw a graph out if you are helped by doing that. But you're just going to read a description and determine, oh, is this going to be a positive or negative or no trend at all. Okay? Go ahead and get started on that.